Hi, I'm trying to walk you through my final project. So let's jump into that. So I'm using the second course option, and it is building a mini search engine. And then yeah, so basically I also built a GUI for this application. And yeah, so basically um so let me do a quick demo on a code on the application. So basically, if you click on choose files, you can choose multiple files. And here I'm selecting the Hugo, Shakespeare, and Tolstoy, the three zip files that was provided to us. So I'm opening it, and then I'm constructing inverted index, and it's going to contact the uh, our server side application and try to build an index on it. So basically, uh, yeah, so basically this would be like the first step in making sure that we're doing it correctly. And then I think once the index has been built, um, we have two actions. One action is search for term, like that was described on the left handout. We can search for like a date, and then it will give us an execution time on this date. So basically it will tell me that in the folder called poetry and then the document called sonnets, I have 20 dates that appear in their file. And for Tolstoy, it has this document and also these frequencies. And we can also like search for another term, like let's say test, and then search will give us a bunch of these. And they're ordered by the frequency they appear in those files. And then, yeah, that's the first functionality of this application. And the second functionality of this application would be um, build a top end index. So basically, if you say like 20, it's going to build the top 20 entries for that for our files. So if we say like n equals 20, then it will show you the execution time and then show you the term frequency of the most frequent words in the files that you uploaded. So basically, we have all those stuff, and we also have because the requirement says we need to build it with a stop word. So I just Google it and insert a bunch of stop words, which are effectively the words that doesn't mean a lot in our analysis. So basically, I use the stop words to filter out the words that are not what we wanted. So basically, if you look at here, there isn't any words that's in the stop list. Okay, so that would be the general functionality and the UI of this application, and I feel like it's pretty comfortable to use. You can do it multiple times with 10, 20, whatever you want. You can search for king and then get all of these. Okay, so yeah, so basically that'll be it for the demo, and so now it comes to the entire code and how I implement it. So oh, actually I forgot to mention we have, let me go to my Google Cloud. Okay, so let me switch to my account. Yep, and let me go to my Kubernetes engine. So basically, I built all of these in. As you can see that like the client side application is in a Docker, and then I'm running Docker locally. But if I want, I can also deploy it to the cloud. Um, so like so I'm having a mini search engine. This is like a cluster, Kubernetes cluster. And then what I do is what I deploy this cluster. And also, if you look at the workloads, and it has this is like a Kubernetes engine server, and then like it has a bunch of, let me see. Yeah, so basically this is like a deployment, and we also have the logs and all this stuff. And then I also built a service, an engine service, which is an external load balancer, and it's responsible for load balancing all those requests. And our external endpoint is the ones that I use. So you can see like right here, I'm using the server side IP right here. So that's the only thing that I need to change every time, because I don't know for sure which endpoint should I connect to. And it's also connecting to 30,000 port. Okay, so yeah, so basically we have all those pods right here, and then we have the service, and what it does is listening for external requests coming from coming to the port 30,000, and then it's redirect to port 30,000 on that machine. That would conclude my short demo. And if we look at my code, I'm using like a Django framework for the backend application, and then I have a static CSS for styling, as you can see in my app, like all the style and all this color for the buttons, and then I have I'm loading a bunch of oh, I forgot to mention, I have a bunch of templates. They're also for like HTML and UIs, and server side application are loaded from the environment variable. So those environment variables are specified in a Docker file. So basically the server side app IP and server side app port are specified right here. And then we're loading in the environment variable right here on these two lines. And then I'm concatenating all those stuff into a single IP that I want to connect to. And yeah, so basically we want to have the first application, the client side application, to work in a way that it's not doing a lot of heavy processing. So like you can see that it's like the upload action, so it's uploading the file. So basically it is when we're like chosen a bunch of files, and then when we click on convert inversion index, so that's how we handle. So when I click on construct inversion index, it will go through all those code, and then it will get the zip file, and then it will send the zip file, basically for forwarding the request to the server side application. So correspondingly, when we are sending this request, you can see it by I'm using like a request.post, and request.url is the local IP, which is the IP address of the server side application. And I can concatenate that with upload files endpoint on the server side. So the server side has an upload files endpoint, which is expecting a post request. And then so if it's a post request, we're handling the file, and then we're saving the file in the location of our choice, and then we're building the index. So what build index does is calling a method in another file, and then what it does is it's using a timer to kind of record the time that elapsed. And we have so basically all those stuff are unzipping the tar file, and then we're processing the zip file we're passing all those files. For each file, I have a hash map for mapping the word and frequency in a single file. So basically, I have something called a file word dictionary, and then in this file word dictionary, we are using a file path, and then so basically it is a dictionary, and the key is file path, and the value is actually like a word dictionary. So basically, the word dictionary will contain the word itself as a key, and the frequency of it appearing in the text as a value. So basically, all those stuff are handling these stuff. Yeah. So basically, it also have a something called a global word dictionary, and the global word dictionary is storing um, storing the sorted version of the global word dictionary. So the global word dictionary record every word that appears in all those files, irregardless of where they're located, what's their parent folder, and what's the file that it extracted to. So basically, yeah, so the global one is just using a big hash map and then storing all those stuff. So speaking of storing the actual hash map into a persistent location for the later maybe like search, all those stuff. I'm using a mechanism where I'm storing all of those dictionary as a JSON. So I write those JSON stuff in the file, and then I'm recording the time it elapsed, and that will be the end for this build index function, and then I'm returning the execution time as well. And for later, when we are, like let me see. So basically, when we are after we constructed the index, we want to search. So basically, let's say I click on date and then I search. So it will be passed in as a search item action, and because when I'm clicking on this search, it is actually corresponding to like a form in this HTML, and then it's sending a post request. And if it's a post request, we are getting all those stuff, and and at the same time, I'm forwarding all those requests. So basically, I'm forwarding the request parameter turn to the other server side application. So basically, when we say like request.post and then local IP plus get frequency, what we're trying to do is we have get word frequency right here, and then we're parsing the parameter, the turn, and then we're looping through every possible file that we already have, and then so we are checking for if this word appears in our word frequency dictionary. So if it appears in our word frequency dictionary for that specific file, I'm extracting its file name and its word, and it's also its frequency. So basically, that's what these code are doing. And then I'm also recording the time and also sending back as a JSON string, and then after all of that, displaying that, passing it back to our template. Where in our template, we're going to have something like I'm using like a Django template language to display all those stuff. So that will correspond to when you click on search, and then all the stuff are displayed right here. And I'm using like a table tag in HTML, and all those stuff are just, like this is the document folder, this is the document name, this is the word frequency. So I did all of those parsing in views.py and my apps.py at the server end. So yeah, so basically, I think the last bit is just top end. So basically, we're typing in a number and then we're searching the topmost occurrence of words in all those files that we uploaded. So basically, for this top end actions, I have a so when you click on like search right here, it is trying to do a post request, and then I'm extracting the value called n value. So basically, what is the n that we want, and upload data is just n value right here, and then request.url. It's doing like the get top and post request. So if I'm at this line, and then the request will be sent right here, and then yeah, so basically, if it's a post request, we are recording the time, and then for the post request, we are looking at the global index table instead of the file-based one, and then we're extracting like the top n words in that file, and because the global index file is already sorted, so that makes all the process effortless. We just use a while loop and then stop when we have more than needed amounts of words. Yeah, so basically that would be just a general idea of how it works. So when the response is passed by, return, and then in this use.py function, I have words frequency map and all this stuff, and of all those parameters, and then in the top end completed, I'm having something like a Django template language, those code blocks, and with those code blocks, I can just display all those items effortless on my UI, on my HTML. So yeah, I think that'll be it for my application. Let me try to look at if I miss anything. Okay, so I think that's pretty much it for yeah. So for Docker to cluster communication, I mentioned that previously, so I just want to reiterate that point. So basically, oh, actually, I forgot all those Docker stuff I need to mention. So basically, like for Django application, I'm using Docker as well, and for the Flask application, I'm using the Docker file as well. So basically, all of these are just I have all those dependencies. I use pip freeze to extract all those dependencies in my application, and I install it when I'm running Docker, and then I'm exposing this endpoint and then this IP, and yeah, so basically that would be the server side port. And once we know the server side IP and the server side port, it will be effortless for us to communicate with the one that's deployed right here, because we're using it as an external load balancer. That make the whole thing very easy. So yeah, so basically, I think that'll be it for my demo. Thank you. You have a great one.